All right, so let's talk about this review that we did in class today. I'm gonna break this video up into a couple of different pieces and do what we reviewed in class today with what we haven't yet talked about during the review. This was the first page that we worked on, and some people had a hard time trying to figure out what it meant. Now, on the copy that you guys got, these actually weren't figures that were in color. They were just in black and white. But remember, these are the actual colors of the pieces that we were playing around with on our desk when we were trying to make all of these different things. So the first thing that I want to remind you of is that we boxed in these words one whole because we talked about the fact that whenever you see one or one whole, it's a fancy mathematical way just to say the number one. So this is telling you that a green triangle means 1. If a green triangle means 1, what we really have to figure out is how many green triangles would it take to make this figure. Now, there's no way that I can change the color of this on paper, but I will show you that if I just draw a line right here, remember when we put two of these green triangles together to make one of these rhombuses or rhombi? So if it takes 2 of these triangles to make this rhombus, then this rhombus equals 2. No fraction, because remember, if this is 1, this figure is more than 1, so no fraction. Now, when I come down to the second one, something is going to change here. It looks like I'm starting with a large piece and going down to a small piece. And this trapezoid is 1. I'm noticing that this green triangle is not as big as this trapezoid, so I'm going to a smaller piece. I'm going to have a fraction. So what I need to figure out, again, is how many of these green triangles will it take to make one whole trapezoid? Well, we went from corner to middle and from corner to middle, and if I had triangle pieces, I could put 3 of them together to make this figure. So that piece is 1/3, that piece is 1/3, that piece is 1/3. So it looks like if a trapezoid is 1, then a triangle is 1/3. So you have to pay attention to what's going to represent the whole, because remember that a green triangle won't represent the same thing every time. Remember our conversations about a half? A half of a school is not as big as half of Virginia. A half of a cookie is not as big as half of a pizza, so even fractions don't mean the same thing all the time. I think you can probably hear the dogs downstairs. So number 3, this time I've got a trapezoid and I'm turning it into a hexagon. If this trapezoid equals 1, I'm noticing that this hexagon is bigger, so I'm not going to need a fraction, I'm going to need a number. And remember in class when we put 2 reds together to make a yellow? So if the trapezoid is 1, this piece is worth 1, this piece is worth 1, so a hexagon must be equal to 2. I'm going to let you finish these 3 on your own for some extra practice, and let me turn the page to the second thing that we did in class today. Now this is like another one of those videos that we did. We have to see if we can figure out this addition sentence based on this model. And the last time that I had a number line, we had to pay attention to the pieces that were equal to 1. So I'm just going to come and highlight this number line until I get to the number 1. And if I do that, I can see that my number line is made of 1, 2, 3, 4 pieces until I get to the number 1. That means any fraction that I make is going to have a denominator of 4. Now my first jump lands here at 1, 2, 3 pieces, 3/4. My second jump is made of 1, 2, 3 pieces, 3/4. Well, we did this problem already. 3/4 plus 3/4 equals 6/4. And another way to look at that is that if I look at my jumps, it passes the number 1, so 1, plus I have an extra 1, 2 pieces. 6/4, or 1 2/4. This next one, I've got to figure out both the mixed number and the improper fraction for this model, but I need some information first. I need to figure out what 1 is. This is a different way to talk about this same idea. So I'm noticing a couple of things here. I'm noticing that this figure equals 1, and this figure is made of 1, 2, 3, 4, 5 pieces. I'm just going to jot that down because that's going to let me know that any fraction I make from these figures is going to have a denominator of 5. So mixed numbers. To get my mixed numbers, remember that a mixed number is a number mixed with a fraction. So let's find out how many figures are totally and completely colored in. Looks like this one is totally shaded. This one is totally shaded. So I have 2 figures totally shaded. 2 totally shaded, 2 is my big number. I come to this last one and I have to figure out what fraction of this figure is shaded. 1, 2, 3 pieces are shaded, so 3/5. One way to talk about this is 2 and 3/5. When it's time for my improper fraction, remember we talked about 2 ways. So first there's the math way. The math way means take my denominator times my whole number. 5 times 2 is 10. And then add your numerator. 10 plus 3 is 13. But if you can't remember all those steps, it's easy with a model, and you will always have a model when you're doing mixed numbers and improper fractions. I could just go back and count how many total pieces are shaded. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 pieces are shaded, so my improper fraction is 13/5. This one confused 1 or 2 people today. We have to write the fraction of the group that are baseballs. So baseballs are what I'm talking about. And remember, whatever you're talking about is your numerator. So let's find out how many baseballs I'm talking about. Well, there's 1, there's 2, there's 3. Since I'm talking about 3 baseballs, that's going to be my numerator, but my denominator, remember your denominator is the total items. So I need to go back and count all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3/12 are baseballs. Connor bought 8 pens. 1, 2, 3, 4, 5, 6, 7, 8. If he bought 8 pens, I can just go ahead and get my denominator ready because it's going to be 8. 3 of the pens were green. So maybe I'm just gonna circle these 3 right here, and I'll use a G to let me know that they're green. 2 of the pens were blue. I'll circle these 2 and I'll put a B to remind myself that those are blue. The rest were black. What fraction of the pens were black? Well, 3 of these are green, 2 of these are blue, and the rest must be what's black. And there are 1, 2, 3 left, so 3/8 are black. Now this page we didn't really have any trouble with except for number 12 here. So let's look at number 12 just one more time. Circle all. Now all is in capital letters, it's bolded, and it's underlined. So remember in reading when we were talking about our text features, somebody is trying to draw our attention to that word all, which means that there's going to be more than one correct answer here. I'm not going to circle just one. I'm going to circle all of the fractions that are equivalent. And remember equivalent, when we wrote the word equal, we discovered that it's basically the same word right here. So just in case you forget, equivalent is a fancy mathematical way to say equal. Now there's a hint. I need to label all, and there's that bold word again, of the fractions first. So let's just go ahead and find out what fraction is shaded. Let's start with this one. I see that there's one piece shaded, so 1. Talking about one piece, so that 1 is my numerator, remember? Now the denominator, how many total pieces are there? 1, 2, 3, 4, 5, 6. 1/6. Here there are 2 pieces. 1 is shaded, 1/2. Here there are 1, 2, 3, 4 pieces. 2 are shaded, 2/4. Here there are 1, 2, 3, 4 pieces. 3 are shaded, 3/4. So far I don't see any that match up. So far it doesn't look like any of them are equivalent or equal. 1, 2, 3, 4 pieces. 1 shaded in, 1/4. Here there are 1, 2, 3, 4 pieces. 2 are shaded in, 2/4. Well, I see something going on here. 2/4 and 2/4 means that these two are equivalent. So I'm gonna circle these two because I know they're the same, but let's just go back and double check. I'm noticing that with this one, it looks like half of it is shaded in. Half doesn't look like it's shaded in here, and more than half looks like it's shaded in here. This one is kind of tricky because it's hard to see half of a triangle. This one looks like half of it is shaded in, so that must mean that these two are equal because the same amount is colored in, a half and a half. So this is my third answer. When I come down to the last one, this is sort of like comparing fractions that I had before, but notice this time there are no fractions for me to compare, there's just a model. It's always good to write your fraction. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces that make up this model. And 1, 2, 3, 4, 5 of them are shaded, 5/10. Over here there are 1, 2, 3, 4 pieces that make up my model. 1, 2 are shaded in, 2/4. So I can do a couple of things here. In my mind, I can sort of imagine that this shaded piece is slidden over to here, and this shaded piece is slid over to here, which means that half of this would be colored in and half of this would not. Here I can sort of imagine that this shaded piece slides up here, so the top half would be shaded and the bottom half wouldn't. But if you're not ready for moving models like that, let's go back to that butterfly and multiply up. 10 times 2 is 20. 4 times 5 is 20. Well, 20 is the same as 20. That must mean that 5/10 is the same as 2/4. So these two fractions are equal.